Hi, good afternoon. My name is Satria Bijaksana from Institute of Technology Bandung in Bandung, Indonesia. And today we are going to present uh, our work on WEPAPIS-60, which is the Western Pacific Paleointensity Stacking for the last 60 kilo years. And this work is collaborative works between myself, my students, and colleagues, both at Institute of Technology Bandung as well as from Universitas Pajajaran, also in Indonesia. Let's talk about paleointensity stacking. Okay, as you're probably aware that for the last few decades, scientists have recorded what's so called the magnetic paleointensity that is basically stored in sediments and rocks and also other materials. And basically, these records of magnetic paleointensity tells us about the history of the Earth's magnetic field that include magnetic reversals and also magnetic excursion. So these magnetic reversals and magnetic excursions have been used as stratigraphic tools. So this is quite important in earth sciences. So sometimes when we have the paleointensity record from one particular source, like a rock or sediments, uh, there's a need to basically improve the quality of the record. And one of the ways to improve the quality of the records is basically by doing what's called the paleointensity stacking. That is to combine the paleointensity records from other data from the same different regions. And we have seen many of these paleointensity stacking that includes the global paleointensity stackings of the last 75 years by Carlo Laz and his co-workers, as well as some other uh, paleointensity stacks. For example, the North Atlantic paleointensity stacking and South Atlantic paleointensity stacking, the NAPIS and SAPIS. The interesting thing about the one of this global paleointensity stacking is that the records were derived from many regions except Western Pacific, and this because there's a limitations of high resolution paleointensity data from these regions. In 2018, our team basically produced high resolution relative paleointensity record of up to 60 kilo years from 10 meters of sedimentary core from Lake Tauti in Indonesia. And with this paleointensity record from Tauti, which is also a high resolution, that now it's probably possible for us to make a paleointensity stack for the Western Pacific. So this is the paper that we published in 2018 at the Physics and Earth and the Earth and Planetary Interiors. So if you could, as you could see from here, the record from Tauti, the TOW109B, it resembles some of the global records, the GLOPIS, and also other records. And it also somehow correlates with less or the lower resolution data from the regions, such as the ODP 768 from the Sulu Sea, the PC 83 from the South China Sea, as well as the MD 97 to 2143 from the West Philippine Sea. But as you could see that there's a slight differences in terms of the record for the Tauti record with the Glopis. As you could see that for the age of 45 kilo years and older, the trends from the Tauti is different from that of the global temp, the global paleointensity stacking. Okay, now let's move to the Western Pacific anomaly. Now, this is the the horizontal intensity model of 2019 from the BGS. And as you could see that Western Pacific has a anomaly. It's shown as a red area, and this is probably much higher than that of other regions in the world. So why Western Pacific has a anomaly, a global anomaly in terms is paleomagnetic intensity. Okay, in this situation, this is the horizontal part. So in 2019, Kupenko and his co-workers basically published a paper in Science uh, that shows. So in 2019, Kupenko and the co-workers published a paper, and this is kind of interesting. So they argue that the subduction slab, even at the depth of 300 to 600 kilometers, could still affect the paleointensity or the intensity of magnetic field at the surface, as this slab contains magnetized hematite that might retain the magnetic remnants affecting the Earth's magnetic field at the surface, basically. As you could see that from one of the pictures of the work of Kupenko et al., you could see that the Western Pacific is anomalous. Okay, so this work of Kupenko basically and combine this work with that of our work in Tauti lead us to think of, can we do something about this? Can we make a paleointensity stacking for the Western Pacific, basically? Okay, so we look at some of the published data from marine sediment cores from various locations in the Western Pacific. The only exception, this is the lacustrine samples from Tauti. The other five basically from marine core. And as you could see that they're spread all over the Western Pacific. And this is the details of the core data. There's one from the South China Sea, PC83, the Tauti Lake, the Indonesia, TOW109B, and there's one from West Philippine Sea, the MD97 to 2143, and then also the Banda Sea, MD012380, and then one from West Pacific, 195, 1202B, and then from West Philippine Sea, the PH05, basically. And as you could see that these cores, they are varied in length and also varied in terms of sedimentation rate. Some would have sedimentation rate, like in Tauti, as high as 19 centimeter per kilo years, but some of the marine cores could be as low as 1.7 centimeter per kilo years. And based on the paleointensity data, the published one, all these core data use different normalization parameter ranging for the isothermal remnant magnetization, IRM, anesthetic remnant magnetization, magnetic susceptibility, and also, yes, yeah, the anesthetic remnant magnetization, the IRM, and also the magnetic susceptibility. They also differ in terms of dating methods. Okay, some use carbon 14, the other one use delta O18, etc. Okay, so we also look at the approximate distance of these locations to the subduction zone. As you could see, we have seen at least three major subduction zone. This represented by the cross section A prime, B prime, and C prime, ranging from the Ryukyu Trench to the Seram Trough and Timor Trough, and also with the longest one from Mariana Trench all the way to Manila Trench. And This is the approximate depth of the subduction plate based on tomography models. And as you could see, these subduction plates basically range in depth in that depth range predicted by Kupenko between 300 and 600 kilometers, and this is the one that probably would have hematite, magnetized hematite. Okay, so this is the relative paleointensity data before processing. You could see that this data differs in terms of resolution, and we tried three different things of three different ways of stacking. One, as model one, we don't have any weighting, so every data is just basically stacked with each other. The second model, we weight based on the resolution and dating methods. So the samples or the core data with high resolution would be given a higher weight based and compared to that with low resolutions, and the one with more detailed dating method is also give a more weight. Okay, so the maximum weight is 2 and the minimum weight is 1. We also look at the third model. This is the weighting based on distance of to subduction zone. Okay, so the one that is close to the subduction zone is given a weight that's less than the weight on the data that is far from the subduction zone, basically. Okay, so this is example of the relative power intensity after the interpolations. So we could see that all the data are combined, and the lowest figure, number of the red one, represent the model one, basically. So this is the stacking without any weighting. Okay, and this is the models that we use for stacking model 1, model 2, and model 3. You could see that there's differences in terms of the results, and basically when we look at the things, we consider that the third model, the stacking model 3, is kind of interesting. Okay, so we propose that this stacking model number 3, the one that took into consideration the distance to the subduction zone, to be the base for our model for the Western Pacific paleointensity stacking, or WEPAPIS-60. Okay, so this is the comparisons of the WEPAPIS-60 with the global paleointensity stacking 75 and the data from Tawuti. As you could see now that the WEPAPIS-60 resembled very close to the GLOPIS 75. As you could see that the trend now is more or less similar to the global paleointensity stacking. Okay, and that's probably all from us, and we thank you for your kind considerations, and we acknowledge the research funding that we received from ITB through the ITB research grant to myself. Thank you very much, and have a good day.